Okay, so the last thing that we're going to do in Chapter 9 is just work this example 9.5, which we're going to take advantage of this new skill that we've learned. Did you know you've learned a new skill? It's a circuit analysis technique that allows us to analyze circuits that have transformers in them. And we're going to use this idea that we developed about shifting impedances and solve a circuit that you have never been able to do before. And hopefully your circuit analysis knowledge just keeps expanding. And you know, here again, and a lot of this stuff, and you'll see this especially if you go on with your schooling beyond us here at Central Piedmont, you know, these ideas, even if you're not using them directly to solve problems, these ideas are important for understanding, you know, and just being able to grasp particular concepts. So let me put the circuit up here and we'll walk through the technique. All right, so before we begin, let's just sort of get an overview of this thing. You know, I've got this 10-volt source that's sinusoidal source, and I've got one inductor here, which would have an X of L of 5 ohms. I've got a capacitor over here, which would have an X of C of 20K ohms. And I've got a resistor here that has a resistance value of 40,000 ohms, okay? Now, what I've got to do is, you know, I'm trying to determine what the voltage is across here. And, you know, this is complicating things, isn't it? If this wasn't here, that would be a pretty easy thing for us to do. And even if we couldn't do it, right, we'd plug it in the multi-sim and let it figure it out for us. But this transformer sort of changes things. And so how do we do this? What should we do? Well, the first thing, you know, that maybe will come to mind now is that, hey, you know, I can work problems like this because I can shift impedances from one side to the other until I get open circuit, no current flowing on one side, and then I can remove the transformer and make certain determinations because of that. And it's all based on the turns ratio. And if I go from here to here, I'm going to multiply that impedance by that amount. And if I go from here to here, I'm going to divide by that turns ratio squared. Okay, so I know that that's the possibility. At first, I might look at this and say, hey, there's just one of these, so I'm going to move it over here. I don't have to do that twice. But then we leave this 10-volt source connected to this transformer, and we don't know what to do with that. We didn't say anything about shifting voltages. We talked about shifting impedances. So that's not going to help us. So the thing that we're going to want to do here is we want to bring these two components to this side, and we want to have them in the same relative position that they are in now. So how do I know what my turns ratio is? Well, it's given to us here. Okay, the turns ratio from primary to secondary is 100. Okay, so what I would do to move this 20K over to the primary side is to take 20,000 and I would divide that by 100 squared. And 100 squared is, what is that, 10,000? So 20,000 divided by 10,000 is going to be 2, all right? And so I got that. And then I'm also going to have to move this guy, and this is what I'm trying to solve for right here, is to determine what that voltage is. And so 40,000 divided by A squared, or 40,000 divided by 10,000. It's going to catch up. Hold on. There it goes. Okay. So 40,000 divided by 10,000, A squared, is going to give me 4. Okay. Now, watch this. I'm going to redo my circuit, my equivalent circuit, and it is simply going to look like this. Okay. Now, that is absolutely something that I should be able to work with. that should be something that I can solve. And so first off, he says, I need to determine what the total impedance is. And I hope you can remember how to do this. Z is going to be R squared plus or minus J. That's kind of bothersome there. X of L minus X of C. Okay, and so what do I have here? I've got 4 ohm resistor squared, okay, plus or minus J, and X of L is 5, and X of C is 2. So that ends up being square root of 4 squared plus J 3, just like that, right? And you know, taking this, putting the real values in here, I end up with 16. Oops, I didn't put the squared sign on any of this. We know that should be the case, I hope. And 3 squared is 9. So 16 plus 9 is 25. Square root of 25 comes out to be 5. So the total impedance in this circuit comes out to be 5 ohms. Okay, so if I have 5 ohms of current and I have 10 volts divided by 5 ohms is going to give me 2 amps. Okay, and that's 2 amps here, and that's 2 amps here, and that's 2 amps here, right? So you know, it follows through the whole thing. So the voltage across that resistor of 4 ohms would be 2 amps times 4 ohms, or 8 volts across there. Okay, so you know, I was able to solve that problem, and you know, it was pretty easily done based on the turns ratio there. And then he goes on to tell us that the actual voltage that we would see based on this turns ratio, right? If this were here in this problem, it's going to be 100 times more than that, or 800 volts there. This is how I get there, you know, working through all of this to get me to that point. But when I move it back to the original problem, you know, this is what I would get. And if he had asked me for the voltage across the 20,000, you know, that would be 2 amps times 2 ohms, 4 times 100. 4 times 100 would be 400 volts here. Okay, and so you know, all of this is pretty straightforward, pretty easily done. I've got 2 amps through 5 ohms here. That would be 10 volts. And of course, it never moves from the primary to the secondary side. And you look at it and you go like, well, gosh, that certainly makes sense, because if I look at this, you know, just this portion of that circuit, there's only one element, so it would have to drop the total voltage there. But anyway, that's a very useful application of the shifting impedances technique that we learned, and we finished up a very good detailed explanation of what an ideal transformer is. And as we progress through here, in whatever area that we're in, if we're looking at this in power systems, you know, when we start looking at, you know, these transformers that have hundreds of thousands of volts, everything still works the same way. Everything, you know, is as it is here. These rules still apply. Okay, so we're done.